Assalamu alaikum. Hello everyone. So today we are just going to discuss about writing and balancing chemical equations, right? Like in paper, even in paper two, like in MCQs, paper and structured questions, they just ask us to write down the balanced chemical equations. So the first part we discussed was writing the correct formula of the compounds, and the next that we are going to discuss today in the lesson is going to be inshallah writing balanced chemical equations, right? So suppose but you like if it's written like the word equation, that is sodium reacting with oxygen. So metal reacting with oxygen is going to form metal oxide, so we're going to get sodium oxide, right? So usually like in the form of, we will be in the past papers, you'll have an idea then. But in today's lesson, we're just going to discuss how to write in the balanced chemical equation. The very first thing that you have to take care of about the diatomic molecules, right? You know what is meant by diatomic molecules? The molecules which exist as two atoms, right? So the diatomic molecules are going to be like halogens that are going to be group 7 elements. They always exist and they're always be written as diatomic molecule, like fluorine, chlorine, bromine, iodine, acetylene, right? So they always exist as diatomic, all halogens, right? And then acetylene as well. Also, other than halogens, other diatomic molecules are going to be oxygen, then nitrogen, and then hydrogen. So whenever you need to write down their names, like in the equation, so you're going to exist them, you're just going to write down their formula as diatomic, right? And hydrogen as well. Okay, so other than halogens, these oxygen, nitrogen, hydrogen is also a diatomic. So whenever you are constructing an equation, so you have to make sure that the diatomic molecules are written as a same way. Okay, and then you have to, the next thing is just to balance the equation. Like diatomic molecules, you have to take care of, and then you have to balance the equation. Or you can say the balance the equation by writing, correct formula of the products formed, right? Just to make sure that the diatomic molecules are written the correct way, write on the correct formula of the products formed, and then you are just going to write, just going to balance. How we're going to balance, I'll let you know. I'll just again erase it and let's complete it in writing, converting this word equation into chemical equation, right? So this is the first thing, Micho, that I do always say, that you have to take care of diatomic molecules. Now see, you will just look at the periodic table and you'll find out the symbol of sodium as Na. So I'll write on sodium symbol as Na. I'm going to write on oxygen as O2 because it's a diatomic molecule, right? Now, the common error done by the students, we just add this together and write on NaO2. No. Remember in our first lesson, we discussed that how you're going to write on the correct formula. Like, we're going to write on the symbol of sodium and you're going to write on the symbol of oxygen, O. Then sodium is in group 1. It loses 1 electron, so we write on 1. Oxygen is in group 6. It gains 2 electrons or share 2 electrons, we write on 2. We are going to cross multiply this. Like, Na will be multiplied by 2 and oxygen by 1. So the formula of sodium oxide will be Na2O, right? So we have to make sure that we are writing the correct formula of the product, right? I hope it's clear till here. Then the next thing is that you can change, you can just balance the equation by, changing the coefficient, right? What is the coefficient? The numbers that you write down, the number of moles or the numbers besides these are known as coefficients, right? So you can balance the number of atoms by writing the numbers over here. Okay. Now see here, if we just balance, there are 2 atoms of sodium, there is 1 atom of sodium. Now if I write on 2 here, oxygen will not be balanced. Okay. So there are 2 atoms of oxygen. So I will start balancing oxygen by writing 2 here. Okay. Now if I wrote 2 oxygen atoms, like then just see how many sodium atoms we have. This number is multiplied by this. That's going to be 2 2s are 4. So I write on 4 sodium atoms. Okay. Now if you just check, our equation is balanced. Okay. Do not forget to count the number of atoms in the end. All right. If you wanted to write down that there were 2, so there are going to be, see 2 oxygen atoms on the product side, or okay. And in the reactant side also, the number of atoms should be same on the reactants and product side, right? Here also in the reactant side, we have 2 oxygen atoms. We have got 4 sodium on the reactant side. We have got 4 sodium atoms on the product side. Okay. So that means our equation is balanced. All right. Other thing is that the state symbols, right? Like you need to specify solid, liquid, or gas, right? But you are going to write on this whenever it is required or when you are doing ionic equations, right? That's just suppose if the like examiner is asking us to write on the state symbol as well. So you know that sodium is a metal, so it's exists as solid. Oxygen is a gas, so it's going to exist as gaseous state. Metal oxides are solid, so we're going to write on solid. Okay, let's discuss one more equation of the oxides. So if I'm writing magnesium plus oxygen is going to give us again magnesium oxide. I'll give you three examples with oxides. So it's going to give us magnesium oxide, right? So you could also try side by side and just check. So we're going to write down the symbol of magnesium is going to be Mg. What should we write for oxygen? O or O2? We should write on O2 because it's a diatomic molecule. We are not writing MgO2. We're going to write in the correct formula of magnesium oxide. Like magnesium is in group 2, it loses 2 electrons, write on 2. Oxygen is in group 6, it gains 2 electrons to complete its octet, write on 2. Remember when you got same numbers, so they will be cancelled. So the correct formula of magnesium oxide will be MgO, right? Then we just have to balance the number of atoms, right? On the reactant side, we have 2 oxygen atoms. On the product side, 1. So I'm going to write down 2 here. Okay. Once I wrote 2 here, so magnesium also becomes 2. So I'll write on 2 here. Okay, so at the end, our equation is balanced, right? Similarly, if I'm just going to write down the reaction of aluminum with oxygen to form aluminum oxide. So let's do this on the next page. Like aluminum plus oxygen is O2 is going to give us aluminum oxide. Formula ALO. Aluminum is in group 3, write on 3 over it. Because it loses 3 electrons, oxygen is in group 6, it gains 2 electrons, write on 2. We are going to cross multiply. So correct formula of aluminum oxide will be Al2O3, right? Then you have to balance, right? Now see here, once if you are going to have even number at one side and odd number on other side, so you're just going to cross multiply. Okay, so like to make the same number of oxygens, I'll multiply 2 by 3, we'll get 6. I'll multiply 3 by 2 to get 6 oxygen atoms, right? Then we just have to see how many aluminiums will be there. 2 2s are 4. So I'll write in 4 aluminium. Okay, so our equation will be balanced. I hope you're getting it. Okay. Now see if I'm going to write down reaction of sodium with nitrogen to form sodium nitride. You know, whenever you're getting I, so that's going to be non-metal ion. Okay, so nitride is going to be ion of nitrogen. Okay, so remember, but I just said to you that you have to be careful about diatomic molecules. So I'm going to write down sodium symbol as Na. I'm going to write down nitrogen as not as N. I'm going to write down as N2 because it's a diatomic molecule. Then I'm just going to convert this into a product. So sodium nitrite, I'll not add this together. Like as a rough work, I'll write down here. Sodium is in group 1, so it loses 1 electron. I write down 1. Nitrogen is in group 5, so it gains 3 electrons. I'll write down 3. They are going to be cross multiplied, so sodium will be multiplied by 3 and nitrogen by 1. So correct formula of sodium nitride will be Na3N, right? I hope it makes sense, right? Now what we are going to do, we have to make the same number of atoms on reactants and product side. If you see over here, we have got 2 nitrogens. So if I write down 2 here to make balance nitrogen, right? Now see, I got 2 nitrogens. Now I have got 6 sodiums, right? 3 2s are 6. So I'll write down 6 here. Okay. So this is our balanced chemical equation, right? I will just give you one more example of polyatomic ions, right? Similarly, like there are some acids, like the reaction of acids with metals, with metal carbonates, and so on. We will keep on doing, right? Just the basics is again and again, I'm repeating the atomic molecules, and we just have to write in the correct formula and just balance the equation by changing the coefficient, not by changing the formula, right? Now, aluminium reacting with sulfuric acid. I'm writing the word equation, but first, sulfuric acid is going to give us which product? Now see, metal plus acid is going to give us salt and hydrogen. So I'm going to get the salt as aluminium sulfate plus hydrogen, right? I have to convert this into chemical equation, right? Symbolic equation, okay? Now I'll also be needing your help. You could also try with me side by side, okay? So let's discuss together. So the symbol for aluminium is Al. Sulfuric acid formula is H2SO4. It's a strong acid which completely dissociate to ions. Formula of aluminium sulfate will be AlSO4, right? So aluminium is in group 3. I'm writing 3 over here. It loses 3 electrons. Sulfate is a polyatomic ion having -2 charge. I write 2 over there. Okay? So aluminium will be multiplied by 2 and sulfate by 3. Remember, whenever you have to multiply a polyatomic ion, I'm just going to write on this in a bracket and multiply by 3. Okay? So the formula of aluminium sulfate will be Al2SO4 thrice, right? Plus hydrogen again, you have to be careful. Hydrogen is a diatomic molecule, bachcho. So we are going to write on hydrogen as H2, right? Now, once you wrote the correct formula of the products and the reactants, then you just have to balance the equation, right? Okay, there are 3 sulfate ions, so I'm going to write down. Like we could balance polyatomic ions as together. Here, just 3 sulfate ions, so I'll write on 3 here. Okay? Now, once I wrote 3 here, I got 6 hydrogen atoms. Here I've got 2, so I'll write on 3 here. Okay? Now, if I just check aluminium, there are 2 aluminium atoms, so I'm going to write on 2 aluminium over here. Okay? Now our equation is balanced, right? Now, see, even we could discuss that whenever that gas is being evolved, the observation is going to be there will be bubbles of colorless gas. There will be bubbles, effervescence, fizzing. All right. A solid disappears, and you can test for you can just identify the gas as hydrogen by using a lighted splint, right? You will just use a lighted splint, it pops. That's a test for hydrogen gas. Okay. I hope, Bacho, these are going to be fruitful for you. I'm just giving you some questions for practice. I'm just writing few equations. You could just try. Okay. So if I'm writing zinc plus hydrochloric acid, it will give us zinc chloride and hydrogen gas. You try to construct the equation, right? I'm going to write down sodium plus chlorine. It's going to give us sodium chloride. Okay, so make sure that you have to take care of diatomic molecules. Hydrogen plus oxygen is going to give us water. Okay, water, you know that what is its formula. So it's going to give us sodium chloride as a product. So side by side, you could just, write down its symbolic equation, okay? So here I'm going to get zinc chloride plus hydrogen gas, right? So try these equations and you can just give me the feedback. Thank you. All the best. Take care.